What's up, guys? Mr. Anziano again here with the backside of 7.1, talking now about the law of cosines. So what we have here at the top is, in order to apply the law of sines, what combination of information within a triangle must be known? Well, from what we saw on the previous page, we needed to know one angle and the side opposite that angle, right? So you must know at least one angle and, not or, but and the side opposite that angle. Okay, so in order to use the law of sines, you must know at least one angle and the side opposite that angle, right? So remember, it was this combination: the sine of angle A over side A is equal to the sine of angle B over the side B, right? So really, I mean, if we look over here on page 1, in order to solve for side C, in order to solve for angle C, we had to first know side C as well. So really, we kind of needed 3 pieces of information, right? We needed the angle B, and we needed the side opposite angle B, and then we needed to create the other ratio, right? Because you can't really solve for 2 variables. You really can only solve for one of these 2 pieces. So we had to at least know the 11 to then find angle C, right? So at least the side, one angle and the side opposite that angle, and then also one of the pieces that you're trying to figure out from that other ratio, right? So either B, the angle B, or the side B. So if you can't use the law of sines, right, what do we do? Well, here's a couple things that would allow us to not be able to use the law of sines. If all we had was side, 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 we would not be able to use the law of sines. If all we had was angle, 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 we would not be able to use the law of sines. And lastly, if all we had was side, angle, side, we also would not be able to use the law of sines, right? Because if you think about that triangle, it would look something maybe kind of like this. If we had that this was 5 and this was 100 degrees, making it an oblique triangle, and we knew that maybe this was 9 over here, well, we don't know that angle that goes with that side, we don't know that angle that goes with that side, and we don't know that side that goes with that angle. So we have to use something else. And that something else is called the law of cosines. Okay, law of cosines is maybe a little scary looking. It goes something like this. A squared is equal to b squared plus c squared minus 2 times bc times the cosine of angle A. All right, now b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of angle B. And finally, c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So all of those equations are probably looking a little bit similar to you, right? If you have an a squared over here, then it turns out we have b squared, c squared, bc, and then finally angle A is back over there. So, you know, kind of familiar, kind of related to each other. But let's see how they work in action. All right. So, given the set of information, we need to solve each triangle. For example A here, all they give us is that A is 6, B is 4, and C is 9. And that also says draw the triangle yourself. So we need to draw that triangle. What's that going to look like? I don't know. Maybe something kind of like where that's 6 and that's it's 4-ish, right? And that would be 9 across. That look pretty accurate? I think so. Not too bad. So we have 4. I just lost my lights. I'm recording this right before the dance concert. Woo, go dance. It's kind of dark. The sun has set, so we're recording in the dark. Anyways, here's 4, here's 6, and here's 9. All right. So what are we going to do with that? Well, we knew that B was 4, so I'm going to label that angle B right there. We knew that A was 6, so I'm going to label that angle A right there. And we knew, of course, then that C is 9, so I'm going to call that angle C right there. So there's my triangle. Okay, so let's solve for angle A. Let's start right here, angle A. Do we know it? We don't know it. We need to find it. So we're going to use this one, right? That gets us the angle A over here by itself. So we have A squared is equal to B squared plus C squared minus 2BC times cosine A. Whew, that's a mouthful. So A squared, which is going to be 6 squared, is equal to B squared plus C squared, so 4 squared plus 9 squared, minus 2 times BC, so 2 times 4 times 9, times the cosine of angle A. There's our law of cosines in action. So that's 36 is equal to, well, 4 squared is 16 and 9 squared is 81. Add them together, we get 97. Minus 2 times 4 is 8, 8 times 9 is 72, cosine A. Alright, let's subtract 97 from both sides, if that's okay with you guys. 36 minus 97 is negative 61. That's going to be equal to negative 72 cosine A. Divide both sides by the negative 72 coefficient that we got there, and we get that the cosine of angle A is equal to, well, negative 61 over negative 72. We can simplify that to 61 over 72 at the very least, right? And we learned today that in order to figure this thing out, we need to take the cosine inverse, or the arc cosine, of both sides. All right. So we have, after all that, a calculator situation. And let's see here. So we want to take the inverse cosine, second cosine, of 61 over 72, and we get 32.089 for angle A. 32.089 degrees. And there you have it. There's angle A. Now, the nice thing about this is I get to do it again, but we don't have to do it a third time. So, what do you want to find next? You want to find angle B? All right, well, let's find angle B. Angle B is right here, so that means that we're going to use this guy, the second one. Whoop, there we are, the second equation there. So we have B squared is equal to A squared plus C squared. Let's see, B squared is 4 squared is equal to A squared, which is 6 squared, plus C squared, which is 9 squared. 6 squared plus 9 squared, minus 2 times side A is 6, right? So 2 times 6 times side C, which is 9, times the cosine of angle B. Okay, so we get 16 is equal to 6 squared is 36, 9 squared is, again, 81, and 36 plus 81 should get us 117, minus 2 times 6 is 12, and 12 times 9 is 108. So 108 cosine B. Again, we subtract 117 from both sides, and I'm going to run out of space here in this box, but that's okay. 16 minus 117 is negative 101, and that's going to be equal to negative 108 cosine B. So then, of course, cosine B is going to be equal to negative 101 over negative 108, which means take the inverse cosine. This is the law of cosines after all. So inverse cosine of both sides of that. And what do we get for the inverse cosine of 101 over 108? Let's see here. Second, oh, we're off the screen a little bit. Second cosine, that's not second, second cosine, there we go, of 101 over 108 equals 20.742 degrees. B equals 20.742 degrees. Okay. Now, we have two angles. We don't need to do this a third time because we know that all of the angles in a triangle add up to 180. So, if I add together 32.089 with 20.742, I get 52.831. And I'm going to subtract that now from 180. Let's just do it all at the same time. 180 minus 52.831 is 127.169. So, triangle, angle, sum gives me that the measure of angle C is equal to 127.169 degrees. And of course we can make sure by looking back at our triangle, would it make sense that that angle is significantly bigger than that one and that one? Yeah, I think so. It's an oblique triangle, right? So it makes sense that one of those angles is going to be significantly larger. In fact, by definition, it makes sense. So there you have it. There's example A, and I am going to leave it at that because I got to get over to the dance concert. So maybe we'll talk letter B next week, guys, but you should have enough to get through the 7.1 practice with that information, and if not, then we'll go over example B another time. All right. Hope you all have a great weekend. See you soon.